everyone, welcome back to my channel Electronics Pivot. In last class I've explained the application of diode, that is wave shaping circuits. So one such wave shaping circuit is clipper that I have explained in previous class, and in today's class I'll be explaining about clamper. So clamper is it shifts the signal. It shifts the given input signal to the voltage required. Say, for example, if this is the signal 0, say if maximum voltage is 5 and the negative peak is also that is minus 5 volt, 5, 0, minus 5. So there are two types of clampers. One is positive clamper and other is negative clamper. So how positive clamper works is that, see, for the input signal, first calculate the peak to peak voltage. Peak to peak voltage is the positive peak minus the negative peak, that is minus 5, so which is 10 volt. This is the peak to peak volt of the given input signal. Now what we have to do is we have to shift the entire signal in a positive direction. Say if you want to shift the signal for the 5 volt, so what you have to do is, the positive peak is 5, so add plus 5. The DC level is at 0, add plus 5. The negative peak is minus 5, so add plus 5. Now see what's the voltage value. This is 10, this is 5, and this is 0 volt. So now the DC voltage is 0. We need the DC voltage now at 5 volt. Now the voltage is, now the signal is starting at 5 volt. Okay, then 5 volt peak is now the 10 volt, so 10. Okay, now the minus 5 is 0. So this is the DC voltage, this is the new DC voltage. This is 0, this is 5, this is 10. So here the signal is shifted 5 volt up, because that's the positive clamper we are using. So the signal is shifted upwards for plus 5 volt. Now what if you need to shift the signal downward, minus 5 volt? So you will be using a negative clamper. So when you use negative clamper, again the positive input peak is 5, the DC value is 0, negative peak is minus 5. This is the given input signal values. So you need to shift the signal downwards, that is you need to shift the signal for minus 5 volt. So just do it, minus 5, and minus 5. So 5 minus 5 is 0, 0 minus 5 is minus 5, minus 5 minus 5 is minus 10. So now the DC voltage, which is 0 for the input signal, is now minus 5. So say if this is minus 5, okay, here it is, the signal is starting. Then positive peak is now 0. Okay, now negative peak is minus 10. Minus 10. 0. So if you see, this is the DC level for the given input signal, and new DC level is minus 5. So this is the given input signal. Here the signal is shifted upwards 5 volt. Here signal is shifted minus 5 volt downwards. So this is the positive clamper and this is the negative clamper. So you can just tell this DC level is shifted. So it is also called as level shifter. So here clamper shifts the given input signal above or below the x-axis, or above or below the DC level, or you can also call it as level shifter, because here the level is at 0 and here it is 5. and here it is -5. So level shifter. So how you can construct this? You can the easy way of constructing the clamper is just have capacitor, resistor, and diode. So I already told there are two types of clampers. First I'll explain the negative clamper. This is the capacitor, diode, and the resistor. So given input signal. So first let's assume the input signal. Say this is the input signal. I'll take the same example 0, 5 and -5. Okay. So now when you use the negative clamper, what happens is that since capacitor is there, it will charge and discharge. So in order to consider the charging and discharging path of the capacitor, we need to assume this entire signal in 4 parts. So this is 0, this is A, this is B, and this is C, and this is D. Okay. So what happens is that first, for all the other circuits we consider like positive off cycle and negative off cycle, but here instead of considering positive off cycle and negative off cycle, we have to consider like falling cycle or falling signal or rising signal. So 0 to A is the rising signal, and this entire, that is, this is rising signal, and A to B is the falling signal, and this is as usual negative cycle. Only positive cycle, assume it as a rising signal and falling signal. So what happens when you apply a rising signal, that is 0 to A? When you apply 0 to A, capacitor will charge to the positive peak, that is plus 5 volt. Here the signal positive peak is at 5. So when you apply 0 to A signal, your capacitor will start charging to positive, so it can charge till maximum, that is 5 volt. So now VC is 5 volt, and when you apply the 0 to A, that is this signal, to the anode, this diode will become forward bias. So for 0 to A, the capacitor is plus 5 volt and diode is forward bias. Okay. Now for A to B, this is falling signal. So when you apply a falling signal, obviously the capacitor will start discharging because the input value is becoming less, 5, 4, 3, 2, 1, 0. So the applied input is getting decreased step by step. So obviously the capacitor will start discharging. When capacitor starts discharging, the diode will turn off, that is, it will go into reverse bias condition. So for A to B signal, VC will start discharging to maximum negative voltage, that is -5 volt, and diode will become reverse bias condition because the anode's voltage will get reduced and diode will go into reverse bias condition. Now the negative cycle is in similar way, B to C. Still the VC, that is, it is discharged because it is falling. This is a complete negative cycle, that is less than 0. So it is still in discharging to the maximum voltage -5 volt, and diode is in reverse bias condition. For C to D also same case. VC will be -5 volt because it is still a negative cycle, and diode is a reverse bias condition. So this is how the clamper circuit works. Now let's find the output for the given input signal. For that you need to apply KVL. For applying KVL, we need to find the current direction. I'll assume the current direction is in clockwise direction. So clockwise is this current flows to minus V into plus V in. So minus V in then capacitor, that is plus to minus, so VC, and again plus to minus, so V out equals to 0. So V out equals to minus VC plus V in. This is the output. So we know the capacitor voltage VC is 5 volt and V in, this is the input values. So input value is varying from 0 to 5 s, then again it is getting reduced 5 to 0, then again 0 to minus 5, then minus 5 to 0. So these are the input values range: 0 to 5, 5 to 0, 0 to minus 5, and minus 5 to 0. That's the input range. So I'll apply for the output. So V out equals to minus 5, first is 0 till to 5, right? 0. So 1, 2, 3, 4, 5. So what is next range? Next is 5 to 0. So minus 3, 2, 1, 0. Next is 0 to minus 5. So you need to reduce this: minus 5, minus 1, minus 2, minus 3, minus 4, minus 5. Next is minus 5 to 0, again it is getting reduced. So minus 4, I'll mention it this way. V out equals to minus 5 plus minus 3, minus 5 plus minus 2, minus 5 plus minus 1, minus 5 plus 0. So these are the input values from the given signal, that is this 0, 1, 2, 3, 4, 5, 4, 3, 2, 1, 0. Again minus 1, minus 2, minus 3, minus 4, minus 5, minus 4, minus 3, minus 2, minus 1, 0. These are the input values range I have mentioned, and this minus 5 is the capacitor voltage. So just calculate this: minus 2, minus 1, 0. This is again minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, minus 8, minus 9, minus 10, that is, this is minus 1, 2, 3, 4, 5, again 4, I did not mention 4, minus 5 plus minus 4 is 1, minus 5, sorry, 9, 8, 7, 6, 5. So this is the output values. Let's plot it now. Okay, this is the old DC value. So let's plot it. The graph is starting at minus 5. Let's assume this is minus 5. Okay. So minus 5, minus 4, minus 3, minus 2, minus 1, 0, again minus 1, minus 2, minus 3, minus 4, minus 6 up to minus 10, then again minus 9, minus 8, minus 7, minus 6 and minus 5. So this is the new DC voltage which is at -5, this is at 0, this is at -10. So I already told, like, this is the input signal and this is the output signal for negative clamper where the level is shifted. So here also the level is shifted. So input signal, so this is the input signal which is at 0, 5 and -5. Here it is -5, 0, 10. Just calculate the peak to peak voltage. Here peak to peak voltage is positive peak minus negative peak, 10 volt. So here also positive peak, that is 0, minus negative peak, 10 volt. So peak to peak voltage is getting matched and the signal is also shifted -5 volt. So this is how you will calculate the negative clamper's output. Just calculate the KVL and then apply the input values with the capacitor voltage value. Hope everyone understood.